HanselMinutes.com. It's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman, hosted by Carl Franklin. This is Lawrence Ryan announcing show number 76, recorded Friday, July 27th, 2007. Support for Hansel Minutes is provided by Telerik RAD Controls, the most comprehensive suite of components for Windows Forms and ASP.NET web applications. Online at www.telerik.com. And by .NET Developers Journal, the world's leading .NET developer magazine. Online at www.sys-con.com. In this episode, Scott talks about F# with Robert Pickering.
Hi, this is Scott Hanselman, and this is another episode of Hansel Minutes, and we are fortunate enough to be sitting down today with Robert Pickering, the author of the Foundations of F# book, and I'm in Portland. Robert, you are where right now?
I'm in Saint-Germain-en-Laye, near Paris, France.
Ah, wow. Well, Robert, I really appreciate you coming on the show. I had mentioned F# in your book on a recent show, and you emailed me and said thanks for the mention, and I was just thrilled to hear from you to be able to get you to come on and talk about it. I'm about 280 pages through the book. Haven't quite made it to the very, very end, but I'm enjoying it. If you could share with the listeners why F# to start.
Okay. Well, it's a very interesting question because F#'s a general purpose programming language. So in a sense, it is kind of competing against the C# and the VB .NETs of this world, which might seem a bit kind of crazy given the small number of people that use it. But I think the .NET platform sort of is a bit of a leveler in that way, in that any library written in C# you can also use from .NET. So it gives you a lot more broader scope.
Now, do you think that it's going to get a bad rap because it's a functional programming language? I mean, I know it's not a pure functional language like maybe a Haskell. Would that be a fair statement?
I think some people might perceive it that way, but I think a lot more people are taking an interest in functional programming because a lot of the features that are being introduced to C#, the next version of C#, are ideas taken from functional programming. Like I know generics is very popular. It was a very popular feature in the framework 2.0, and that's an idea largely lifted from functional programming. I know it sort of also looks a bit like C++ templates, but I think the idea of type parameterization very much comes from functional programming. So I think that sort of thing is sort of making people sit up and say, hey, we should maybe take a closer look at this functional programming. I think that's one of the aims of the F# project, is to let people that maybe haven't had so much exposure to functional programming and program more in C# and just give them some exposure to that, and also to try and draw in some people that have maybe done some functional programming in OCaml or Haskell or languages like that, and maybe wouldn't have otherwise thought of looking at the .NET framework, and letting them look at the .NET framework and see what a nice environment it is to program in.
Would you say that F# is an actual functional programming language like OCaml or Haskell, or is it like more FP like Lisp?
I'd say it's very much a functional programming language like OCaml. I mean, the idea of F# started out to do an OCaml-like language on the .NET framework, and I mean it still is very much like OCaml, but it's also drawn influences from other languages like Lisp and Haskell and even C# in some ways, because the object system it uses is very much like the C# object system.
Can you help me put my finger and maybe the listener's finger on what it means to be a functional programming language? I don't think everyone who is listening necessarily went to university or paid attention in the functional programming portion of university, and it'd be useful to understand, at least from your perspective, what is the definition? When does a language become a functional programming language? Is it about the statelessness? And if so, what does that mean?
Okay. A lot of people tend to focus on the statelessness of the functional programming languages, and in a pure sense, that I guess that is what, when people say functional programming language, they really mean something that is stateless. And I guess that really means that a function takes its parameters, it transforms those parameters into new values and returns those values. So it doesn't have any side effects. It doesn't alter global states. It's not returning the variables that the parameters that it's taken altered. It's taken a fresh copy of those parameters. So everything's done in a read-only, stateless manner. But for me, I don't think that's the really important aspect of the language. I think perhaps one of the most important aspects of F# is that, well, there's two actually. There's that all values all functions in the language are also values. So that means that you can pass a function to another function as a parameter. And I mean, that doesn't sound incredibly interesting in itself, but it does mean that you can do some really nice things in terms of abstracting flow control, and refactoring your code to be a lot tighter and more concise. And by abstracting flow control, I mean doing things like, say you have a list of values. You can write a generic function called a map to transform that list of values into another set of values. So rather than having to write, say, a for loop over the list. And the other idea is that the language is a bit more value orientated in a language like C#. Everything's a statement, so everything is kind of a list of instructions. Whereas in F#, everything is a value. So, for example, in F#, an if statement returns a value, which doesn't sound a major thing, but there's a couple of things that's quite nice about that. So, in C#, say quite often you want to create one value. Say, initialize a string to be one value or another value based on, let's say a Boolean. And you can use an if statement to do that in C#, of course, but in C# you have to sort of declare your value before the if statement and then set it in either side of the if statement. And you've got no real guarantees that that's happened by the compiler. Whereas in F#, you can just say your value equals and then have your if statement, and the compiler will check that each side of the expression evaluates to a string and is assigned to the value, the identifier correctly.
Are there ways, I mean, as you're saying this, I'm trying to put it into the context of C#, which is kind of the language that so far in my life is spoken by my own, DNA. Everyone finds their language. It sounds like you found F# as the one that spoke to you. Yeah. And I'm always looking at other languages, trying to see if maybe this next language will be the one that speaks to me. So as I try to get my brain around F#, I'm asking myself, well, you said functions are values, all values are functions. I mean, how is that different from being able to pass functions around as delegates and function pointers and things like that?
Well, it's incredibly similar to a delegate, actually. It's just a bit more of a generic mechanism. I think delegates are incredibly useful, but you've sort of got this limitation that each time you want to use a delegate, you have to go and define it. And you get this kind of annoying things where you can get two delegates with exactly the same signature, but they're not quite equal. So you end up defining you could end up defining the same delegates in several places that has the same signature.
There's definitely a lot of prep work. I know that I never use delegates without thinking about it ahead of time. I always have to go off and prepare the program for this delegate that's coming along. Now, that changes a little bit with anonymous delegates, but I get the impression that in F# you don't give throwing a function around any thought at all.
Yes, that's the idea, that you can do exactly that, and it does end up making your life easier in that what I find when I'm coding, you quite often get into situations where you've got two functions that are very similar, but maybe there's a bit at the beginning that's similar, then a bit at the end that's similar, and then there's a small section in the middle that changes. Now, in C# that's a little bit difficult to refactor into the same function, because you end up having to put an if statement in the middle to do the two different things, whereas in F# you could just make the two the same function and have the middle bit as a parameter. I saw somebody blogging about this recently, calling it the sort of, what do they call it, the hole in the middle pattern.
So how does this relate to this concept of curried functions or partial functions?
Well, the idea of curried functions is, in my opinion, it's kind of an overstated feature in functional languages. It relates to the all values being functions, in that what a curried function is, if you don't pass a function all of its parameters at once, it will return a function that's kind of waiting for this final parameter, and that can be quite useful in some situations, but it's not sort of my favorite feature, and it does put a few people off, I think, just because it can seem to add a bit of extra complexity, whereas
one of the things that I thought was interesting, if I'm understanding this correctly, is that the control flow concepts in F# are very strong. You can't have an if without an else. Is that true?
Yeah, that's sort of going back to what I was talking about earlier. Is you can have an if without an else, but the compiler will check that your if statement evaluates to be unit, which is F# version of void. So is something with a side effect. Whereas if you have an else, it will make sure that both sides of the else clause evaluate to be the same thing, which is it's very useful for catching errors when you make small mistakes in an if then else statement. In an if then else statement, then the compiler can type check that for you, which is something you don't get in C#.
So in that case, then the if then else kind of construct is itself it's an expression. It's a
value.
It's a value. It evaluates to a value, and that value must have one type.
Yeah, exactly.
So then F# is a strongly typed language.
It's very much a strongly typed language, but I think one of the things I like about it, although it's strongly typed, it's still quite concise, because in F# we have what's called type inference, where each value has a type, but the compiler works it out for you. So a lot of the time you don't have to type out the name of the type. The compiler will just look at the functions you're calling and the literals you're using and say, okay, this should be of this type.
So the strong typedness does not necessarily mean that you have to figure out the type ahead of time, like saying int I, like in C#. It's kind of more like C# 3.0, where you know the type. Because of the way you've written the literal, the type can be easily inferred. It may look dynamic, but ultimately you get all the performance benefits of a statically typed language. That's
exactly it. It's in F# you have to bind a value to an identifier, use the keyword let, which is a bit like C#'s var, C#3's var, except in F# that's a default. So, and you don't normally write any other type annotations. And you can put that bit in too if you want, but that's kind of an optional extra if you want to give the compiler, if you feel you need to give the compiler some hints about what you're doing.
Now, one of the things that I thought was actually one of the part of the book I spent the most time looking at, just because it took so much brain power to get my head around, was the pattern matching.
Oh, okay.
Now, it was very clear, but I had to look at the book very carefully and read each, word and digest it. I kept trying to see a switch statement, but pattern matching seems to be more than that. Can you talk about pattern matching and why that's unique to F#?
Yeah. There's a couple of things that are really nice about pattern matching in F#. It is like a switch statement on steroids, I guess. I remember a while ago, one of my friends asked me, why can't you in C# say type of and then do a switch statement over that? In F# they provide some syntax to do exactly that, so you can pattern match over the type of an object. So say you have an object, you don't know whether it's a string or an integer or a float, you can do a pattern matching over that, and run different code depending on what the value is, which is quite a useful little feature. And you can also pattern match over just values. You can sort of say this number, if it's 1, do this, if it's 2, do that, or if it's n, do another, so any other value. And this will all be checked by the compiler to make sure that you have a complete set of values. If you don't, it will give you a warning, which is something you don't really get with an if statement in C#. And also it goes hand in hand with another feature of F#, which I really like, called union types. And union types are interesting because they're not anything to do with functional programming per se, but they tend to crop up a lot in functional programming languages and not really much outside them. And so the idea of a union type is it's a way to model things that are related but are not necessarily don't necessarily share the same structure. That might seem slightly bizarre if you're coming from an OO world where you kind of used to building a hierarchy, so you start off with an object with the fixed number of fields of properties, and then you can kind of add stuff. Whereas a union type is a way of saying this value will have a structure that looks like this or like this. And is it like a union in C?
A union in C, I thought of as kind of being like a struct, but it was a cop-out.
Yeah, it's not really like a union in C. I think some of the extensions to the C language do sort of introduce a kind of discriminating union type, but it's kind of quite a bizarre thing in C.
So when would you know what's an appropriate example, or when would you know that a particular problem was aching for a union type?
Well, there's a very simple example in the F# base libraries, which I really like, called the option type. And this is a union type that has one constructor called sum, which is can be of any value. Another constructor called non, which has no value associated with it. And so when you'd use this is places in maybe a C# library where you would return null sometimes. So say in an XML library, if you're doing select for a node and it didn't exist, in F#, if you're building that library in F#, you'd probably return an option type, which would return none if the value didn't exist, and then sum with the value itself if it did exist. And then what that gives you is a very clear indication that, that there can be two different situations, which you don't really get when you're returning null. I've seen a lot of bugs in code pop up because, functions do occasionally return null, and the programmer's not actually realized that can be the case. And so later on this value is null and you get a null reference exception. Whereas with this option type, the program is forced to write code for the case where the value does exist and when it doesn't.
So then in in F sharp, the kind of type that I would use that would feel like a structure or a class would be a record type.
Yes.
And then the union type offers you this extra level of flexibility.
Yeah. So F sharp has record types which look very similar to which are just a collection of fields like you get on an object, and then this union type is just something that you'd use I guess when a field just doesn't feel appropriate. I mean, another interesting example of where a union type is appropriate is if you were trying to model a binary tree.
Okay.
I think most people have had to deal with one of those at some point. And it's very feasible to model that in a language like C#, but you always end up using this idea of having null references in some cases, which can be a little bit dangerous. Whereas in F# you can just say a binary tree is made up of either a value or a node which has two child nodes. And then to work with that, you pattern match over it so that you write code for the case where you have the two child nodes on your right case where you actually get your value.
And one of the other things I wanted to talk to you about was the F# libraries, because as with all languages, the power of the language is only as kind of exploitable as the libraries underneath. And just as Ruby has Rails and other extensions to Ruby that sometimes people think of as being part of the language but are really part of the library, there's some pretty interesting libraries that come along with F#, particularly around collections and sequences.
Yes, this is going back to sort of the map functions and the fold functions that I was talking about earlier. So I guess it's because of this idea of being able to take a function as a value. You can then take a very generic view of the world and say, so as a programmer, one of the 10 things we tend to spend a lot of time doing is working with collections. And then there's fixed sets of things that you always want to do to a collection, like maybe change it into another collection. So that's a map function. And we can write a generic function which applies another function to each value in the list to turn it into a different value. Or we might want to create a summary of that list. Say we have a list of integers. We want to total them. So we get, in this case, a generic function called a folding function, which takes a function which shows which will be applied to each member of the list, and also an accumulator which will be used to accumulate the value. In the case of making an addition, it would, your function would just be adding the value to the accumulator.
And to be clear, this list is a specific Microsoft.fsharp.collections.list. It's not an iList, or it's not a
it is a collection built into F#. But it does support the IEnumerable interface. So, for example, if you return an F# list to a C# API, you'll still be able to do a for each over it.
See, that gets into my question about interoperability. If I do something in F# that perhaps I'm doing it in F# because it's very elegant, it's very simple, it's a natural thing to do, moving through a matrix or creating a list of some kind, and then I return it out, what kind of dependencies do I have? And even though the type might underlying be an F# list, it sounds like as long as the appropriate system.collections interfaces are implemented, C# will never know the difference.
Yeah, you can create very good interop with C#. Certainly using C# functions from F# is a doddle. Is very straightforward. If you want to create APIs that in F# that look nice from C#, you do have to be a little bit more careful, because F Sharp does have a few weird types like union types, which don't look so great when you return them to C Sharp. I mean, they are usable from C Sharp.
So what kind of problem am I going to want to watch for as a developer where I might see that problem and say, oh, I could do this in 1,000 lines of C Sharp, but this kind of thing is so much more easily cracked by using F Sharp?
I guess it's anything that's sort of very focused on algorithm type programming, or anywhere you have to manipulate any kind of tree, or F Sharp's got great tools for parsing text. So any kind of parsing text or even binary data works really well in F Sharp. And also, if you wanted to do sort of language-oriented programming, what
does that mean?
Well, it's there's a lot of different people given different meanings to it in the industry. But I try and talk about it in one of the later chapters in the book.
Yeah, chapter 11 is on language-oriented programming. That's actually the next one. I'm stuck on chapter 10 on distributed applications right now.
Okay, but well, I think that's one of the strongest chapters of the book, the language-oriented programming. Certainly Don Syme said it was his favourite. And what it basically means in this context is, or what you can do really well in F Sharp that you can't maybe do so well in other languages is design data structures that look like a little language inside of
like a DSL, a domain specific.
Like a DSL, but yet still in F Sharp, still within your programming language. One of the really nice examples of this is F Sharp. One of the F Sharp libraries has got an argument parser built in. And I don't know if you ever tried to write a command line argument parsing. It's not that difficult, but what you tend to end up writing is a lot of in-string and just sort of dirty string manipulation.
Right, it's a bunch of shuffling data around and marshalling from type to type.
Whereas in F Sharp, what you do is you just write a list of pairs of values, one of which is a string, which is the argument you're expecting, and then the other tells you what type of argument that should receive, and generally you pass a function to that to say what should happen when I receive this with this value. So it turns what's usually a lot of nasty kind of string manipulation into something that just looks like a description of what should happen.
Now, would this be using I understand that F Sharp actually has its own Lex and Yak implementations.
Well, that particular example isn't using the Lex and Yak implementation, but I guess that is another aspect of language-oriented programming, and it does have its own Lex and Yak implementation, as you say.
No, we recently had John Lamb from the Iron Ruby team and the DLR come by.
Right.
And a lot of questions came up around what's a good language in the .NET framework, in the .NET ecosystem, really, such that one could create a DSL. Ruby really lends itself to creating its own DSLs. And one of the questions from the audience was whether or not the DLR and or Iron Ruby would really lend itself to creating tiny little languages. And it sounds like F Sharp might be a better place to start if one were going to create their own DSL.
I think F Sharp would be a great place to start. I mean, the company that I work for at the moment, Lexify, does a lot of work with DSLs. In fact, all our products are based around a DLSL for describing financial products, which is actually written in OCaml, but it could be written in F Sharp. It's using the same kind of ideas that are available in F Sharp.
Now, did you have to do anything to sell this, kind of quote unquote, sell this idea to your company, or because you were already using OCaml, it was an easy sell?
The
reason I ask is I'm trying to understand how can I or the .NET oriented listener, sell an F Sharp project to their boss. I mean, Yeah, I think it's fair to point out or remind the listener that this integrates nicely into Visual Studio 2005, right? You get syntax highlighting and all that.
I mean, the integration with Visual Studio 2005 isn't yet perfect, but I mean, you do get very good IntelliSense that works really nicely. You get the F# interactive console is integrated into Visual Studio, which what that means is you can sort of highlight a section of your code, as you might do with a section of SQL that you're writing, and press a keyboard shortcut, which is Alt-Enter in F# case, and it goes off and executes that code for you. And because of the structure of an F# program, it generally lends its well to having kind of little sections of it executed on its own. So it's great for kind of testing your program. And it's particularly nice when you're working with WinForms, because what you can do is sort of pop up a form and then dynamically set properties on the form and see it changing before your eyes, which is really quite cool.
Yeah, that's interesting that the Iron Ruby guy John Lamb did a similar demo, and it seems like more and more people are using demos like that as a way to kind of show the usefulness of an interactive console. It was pretty cool to see him bring up a WinForm app and start adding buttons to it kind of dynamically in a quick prototyping way. Yeah, not to pit you guys against each other, but I think I'd be interested in understanding where a dynamic languages like IronPython sit in the ecosystem next to statically typed but very, very differently powerful languages like F# in the kind of this new world order. Suddenly we have a lot more to choose from than just C# and VB. It's almost like the promise of .NET from 7 years ago is really happening.
It does feel a lot more exciting, I have to say. I mean, one of the reasons that got me into F# originally is when you looked at VB and C#. I mean, I really like both those languages, but if you do put them next to each other and compare them, especially the early versions, that they were really quite similar. One of the things that attracted me to F# was, you really can see differences, different ways of doing things.
Now, one thing we're getting towards the end of the show here. We're coming up on a half an hour, but one thing I wanted to point out that I thought was particularly interesting was that you actually ported the Game of Life sample to Silverlight.
Yes, that's correct. So, yeah,
so how is that Silverlight? We'll talk IL. So you just referenced the correct Silverlight assemblies, and Silverlight didn't even know F# was involved.
Yes, that's pretty much it. Yeah, you can just tell F# to use a particular instance of the CLR. Don Simon spent quite a lot of time working on that, so that the actual F# compiler can be used with the Mono or or Rotor as well.
So you've got standard .NET Framework, Rotor, Mono, and Silverlight.
Yes, so it's all about just being able to reference the right set of .NET DLLs.
Do you know if any particular work had to be done to get that to work with Silverlight, or did it just work?
It just worked. I mean, there's a few things that didn't, in that if you touched on any method that existed in the .NET Framework 2.0 but didn't exist in Silverlight, you got a missing method exception. But generally that was quite easy to debug because it just said missing method so-and-so doesn't exist, and you kind of thought, well, can't use that API. But I mean, it was all stuff that you didn't really want to use, like closing, shutting down the application, because obviously that's not very desirable in a browser.
Well, I am really enjoying your book, Foundations of F#. It's one of the yellow and black books from A Press. And I got to get through Chapter 10 and move on to Chapter 11 on the DSL and language-oriented programming. What would be a good way for the listener to start with F#? I noticed that Don and team just released a new version of F#, kind of on the heels of all of the different releases this week. F#, I think it's 1.9.2.7, with a number of new new language features and such. And it integrates again nicely with Visual Studio, so you don't feel like you're out there at the command line and all alone with Notepad. But what's a good project for someone to sit down with and kind of get their brain around this?
That's a very good question. Well, I think F-sharp's distributed with a lot of samples. I guess a good way is to take a look at the samples available. The Game of Life sample that you mentioned earlier is one of the most advanced that comes with the compiler itself. And otherwise, there's various other ones. And another good way would be, I guess, to talk to the people on the hub. F-sharp has its own community site, started by a guy called Option Scalper.
And where is that site?
So that's cs.hubfs, all one word, .net.
All right, and I'll post that link up on the show website.
Yep.
Fantastic. Well, I really appreciate you taking the time to call us.
Okay, no problem. It was really nice to speak to you.
I do appreciate it. This has been another episode of Hansel Minutes, and we'll see you next week.